Imagine walking through, like, the dense, muddy forests of 1840s Ohio. You're hacking your way through this incredibly thick underbrush.
Oh, and the mosquitoes are just absolutely swarming everywhere.
Right, exactly. And you finally decide to cut down this massive, maybe 800-year-old oak tree just to clear a path.
This could get your bearings, yeah.
Yeah. But when the trunk finally falls and the dust clears, you look down and you realize the hill this ancient tree was growing on, it isn't a natural hill at all.
No, it's an earthen wall.
It's a wall. And as you trace that wall through, like, miles of untamed forest, you discover it forms this perfectly engineered geometric octagon built by some entirely vanished civilization.
I mean, it completely shatters your understanding of the landscape. Suddenly you're standing inside a prehistoric monument of just staggering proportions.
And you have absolutely no idea who built it.
Right. Who built it, when they built it, or, why.
Well, welcome to another deep dive into the source material. We are so glad you are here with us today.
Yeah, thanks for joining us.
Today we are opening up a text that is, well, it's essentially the holy grail of American archaeology. It's called Ancient Monuments of the Mississippi Valley.
Written by E.G. Squire and A.H. Davis.
Right. Published back in 1848. And this book is so foundational that it was literally the very first volume ever published in the Smithsonian Contributions to Knowledge series.
Which is really a testament to the sheer weight of this work. I
Yeah.
mean, before this book, there really wasn't a scientific discipline of archaeology on this continent.
Not at all.
This text completely set the baseline.
So our mission today for you is to explore the breathtaking scale and the deep mysteries of these ancient earthworks of North America.
Yeah.
But crucially, and this is the really important part, we're going to focus on how Squire and Davis actually pulled this off.
Yeah, the methodology is wild.
It is. We're going to look at how they pioneered rigorous field surveys and ensured strict scientific accuracy in an era that was, frankly, completely dominated by wild myths and armchair speculation.
And we really need to understand the climate of the 1840s to appreciate their achievement. Because, as the American frontier pushed westward and these massive, inexplicable structures of Earth were being revealed.
I mean, we're talking thousands of mounds.
Thousands. Giant earthen walls, perfect circles covering hundreds of acres. People's imaginations were just running completely wild.
Okay, let's unpack this.
Yeah.
Because the level of speculation was, well, it was off the charts. You had popular books and newspaper articles claiming these mounds were built by, like, ancient giants.
Right, or the lost tribes of Israel.
Yes, or wandering Hindus. Some people even claim they were built by refugees from the lost continent of Atlantis.
It sounds funny to us now, but this was serious public discourse.
Because there was this underlying prejudice, right? This idea that the Native American tribes currently living in the region couldn't possibly have engineered these structures.
Exactly. So 19th century society just started inventing these incredibly romantic, fabulous origin stories to explain it away.
And that is exactly where the newly formed Smithsonian Institution comes into play. James Smithson, who was an English scientist, he had left his fortune to the United States
to found an institution for the, quote, increase and diffusion of knowledge among men.
Right. But when the Smithsonian was actually established, they had a real problem. They had to decide what actually constituted knowledge. Like, how do you filter out the giants and the Atlanteans?
You do it by creating an uncompromising standard of evidence. The Smithsonian laid down some incredibly strict rules for publication.
Like, really strict.
Oh, yeah. For a memoir to be published by them, it had to rest entirely on original research. It had to provide a positive addition to human knowledge.
Most importantly for our story today, absolutely all unverified speculations had to be rejected.
Tossed out completely. And what's fascinating here is that the Smithsonian didn't just take Squire and Davis's word for their findings.
But they did.
They submitted the manuscript to a rigorous peer review commission set up by the American Ethnological Society.
And this commission included some serious heavyweights of the era, like Albert Gallatin, the former Secretary of the Treasury.
A brilliant scholar in his own right. And Gallatin and the committee reviewed the work and explicitly praised Squire and Davis for their love of truth.
I love that phrase, love of truth.
Right. They noted that the authors completely eschewed what they called fondness for the marvelous, which had plagued literally every other piece of writing on Western antiquities up to that point.
So to get that kind of praise, Squire and Davis had to make a vow before they even stepped foot into the field. They promised to abandon all preconceived notions.
They decided to start de novo, from scratch.
Yeah. They approached these monuments as if nothing had ever been written about them before. No giants, No lost tribes,
Yeah.
just dirt, geometry, and whatever the empirical evidence told them.
Because the Smithsonian's rules forced them to rely entirely on what they could measure, weigh, and map.
Right, if they couldn't mechanically verify it.
It didn't go in the book, period.
But, okay, that raises a massive logistical nightmare. Because how exactly do you map a prehistoric civilization when all that is left are overgrown piles of dirt hidden under centuries of old-growth forest?
It's incredibly difficult.
You can't just stand on a hill and sketch what you see.
Right.
The sightlines are completely blocked by trees.
Right, you can't see 50 feet in front of you, so you have to invent a methodology for the field. You have to put boots on the ground and rely on the art of the scientific survey.
And their methodology was elegant in its simplicity, but incredibly demanding in its physical execution.
Very demanding. They relied exclusively on the surveyor's compass, the measuring line, and the rule.
And we should talk about the sheer physical reality of using those tools in the 1840s wilderness. Because a surveyor's compass isn't some little plastic thing you hold in the palm of your hand.
Oh no, it's a heavy brass instrument. It's mounted on a tripod. It has these sighting vanes.
And the measuring line was often a gunter's chain, right?
Yes, a literal heavy metal chain that you had to physically drag through the mud.
Over massive tree roots, across uneven terrain, up and down hills.
It's exhausting work. And there is absolutely no eyeballing allowed, no estimating distances by, just pacing them out.
Every single angle, every single length was mechanically verified.
Which brings us to one of the most remarkable parts of their survey, which is the circle test.
Oh, this is so cool. So Squire and Davis were looking at these massive circular earthworks, right? And some of them are a mile in circumference.
Huge.
And they needed to know scientifically, are these actually true circles? Or are they just rough, blob-like loops that happen to look roundish to the naked eye?
To prove they were perfect geometric shapes, they devised a brilliant method, which is detailed right there in the source text.
So what did they do?
They raised flags at regular intervals along the top of the embankments. Specifically, they set these stations exactly 300 feet apart.
Okay, 300 feet apart.
Then, they placed their heavy surveyor's compass alternately at these stations, sighted down the line to the next flag, and calculated the bearings.
Okay, so if the structure was a true circle?
Then the angles between these stations, measured every 300 feet along the entire circumference, would match perfectly. The mathematical progression of the angles would be flawless.
The angles matched perfectly.
Perfectly!
Which is insane. Stop for a second and think about the implications of that for you listening. You can't just draw a circle that is a mile in circumference by tying a rope to a center stake and walking around in a loop.
No, a rope of that length would weigh an incredible amount.
It would stretch.
It would stretch, it would sag, it would snag on trees and boulders and brush.
It's physically impossible to use a simple radius line for a structure of that magnitude.
Absolutely impossible.
Mm.
To build a perfect circle on that scale requires an advanced understanding of geometry and a sophisticated method for keeping a consistent curve over vast distances without a central anchor point.
But it wasn't just the circles that blew their minds, it was the squares.
Oh, the squares are fascinating.
Right. Through their strict standardization of measurement, Squire and Davis discovered mind-blowing geometric consistency. They mapped multiple square enclosures, separated by miles and miles of rugged terrain.
Different river valleys, even.
Yeah, and they found that these squares measured exactly 1,080 feet on each side.
1,080 feet? Repeated flawlessly at entirely different sites.
I mean, the exactness of those 1,080-foot squares proves beyond a shadow of a doubt that the ancient builders possessed a standard of measurement.
They had their own version of a meter or a yard.
Right, and if they didn't have a written language that has survived, how are they communicating that exact standard unit of measurement across hundreds of miles?
Well, that's the genius of the architecture. The structure itself is the record.
Wow.
And laying out a square that is 1,080 feet on a side requires 90-degree angles that are absolutely true.
Because if you're off by even a tiny bit...
If you are off by even half a degree on your first corner, by the time you try to close that square nearly a mile later, your walls will miss each other entirely.
They just won't line up.
Exactly. They had the means to determine precise angles without the modern magnetic compasses that Squire and Davis were using.
So Squire and Davis are tromping through the mud, dragging their metal chains, plotting these incredibly precise angles. And as they accumulate all this data, their measurements quickly reveal that the earthworks were divided into two distinct categories based entirely on their design.
Because the architecture dictates the purpose. As they mapped, a really clear pattern emerged in the landscape. The first category they identified were the defensive works, the fortresses.
And the way they deduced this is really a masterclass in reading topography, because defensive works were always located on naturally strong, easily defended positions.
Right, we are talking about the tops of steep bluffs, or peninsulas formed by the sharp bends of rivers, where nature has already provided a wall on three sides.
Topography was the first clue, but the engineering itself confirmed it. Because in these defensive works, the ditch, the fosse, was almost always on the outside of the wall.
Which is exactly what you see in medieval European castles or modern military bunkers.
You want the enemy to have to climb down into a trench, right?
Yeah.
And then scale the steepest part of the wall while you are firing down at them from above.
Exactly. And they also documented complex overlapping gateways. Instead of just leaving a gap in the wall for a door, the ancient engineers would overlap the walls, creating a narrow, winding corridor.
So attackers would have to funnel through this maze.
Funnel through, slowing them down and exposing their unprotected flanks to the defenders standing on top of the walls.
The text actually highlights the fortified hill in Butler County, where Squire and Davis even found stone pavements and earthen lines specifically built to cover the entrances.
Yeah, it was serious life-or-death military engineering.
But here's where it gets really interesting. When you look at the second category of earthworks, the symmetrical works, the contrast is absolutely stark.
Night and day.
If the defensive works are like military bunkers built for survival, the symmetrical works are like grand cathedrals.
Yeah, the sacred works were almost never built on high defensible ground.
No, they were down on the broad, flat, fertile river terraces.
And instead of following the irregular, jagged contours of a hilltop, they were characterized by that perfect geometry we just talked about. The exact squares, the perfect circles, and the massive octagons.
And here is the mechanical clincher that proves they weren't forts. In these symmetrical works, the ditch is almost always on the inside of the wall.
Which is completely useless for defense.
Totally useless. If you are defending a wall from an invading force and the trench is behind you on the inside, you have nowhere to retreat.
Right. The enemy has a clear, flat run at the outside of your wall, and if they breach it, you are trapped in your own ditch.
It's a death trap.
So the interior ditch proves these structures had a different, likely religious or civic purpose. It was perhaps meant to separate sacred ground from the mundane world rather than to repel an army.
The ultimate example of this civic architecture has to be the Newark Works in Ohio. According to the source material, this single complex covered an area of 2 miles square.
It's massive. It featured a huge octagon connected to a perfect circle by parallel walls that form these broad, sweeping avenues.
And presiding over it all was the observatory mound, this massive elevation that overlooks the entire Newark complex.
When you look at the Newark Works, you are looking at pattern recognition at a societal scale. The ancient builders weren't just throwing up dirt randomly.
They had a plan?
They had a highly organized society with dedicated military engineering for times of war and dedicated civic or religious architecture for times of peace.
That level of societal organization totally shatters the 19th century prejudice that these were just primitive, wandering hunter-gatherers.
Absolutely shatters it.
But mapping the surface, tracing those walls with a compass, that was only half the job.
Right, because to truly understand the scientific accuracy of Squire and Davis, we have to look at how they investigated the inside of the earthworks.
They had to get their hands dirty. They had to invent a way to look underground without destroying the very thing they were studying.
And the transition from surface surveying to excavation is where their methodology truly shines. Because before Squire and Davis, excavating a mound usually meant some treasure hunter with a shovel hacking recklessly into the side of a hill until they found a shiny rock or a bone.
Completely ruining the structural integrity of the process.
Destroying all the context, yeah. But Squire and Davis applied strict engineering principles to their excavations. They didn't just dig a haphazard hole.
No, they sank precise vertical shafts, typically 5 to 9 feet square.
Directly from the apex, the very top of the mounds, straight down to the original ground level.
And if they needed to explore the base further, they would push horizontal drifts or tunnels outward from the bottom of that central shaft.
And as they dug these vertical shafts, they didn't just shovel dirt into a pile and ignore it. They actively read the dirt.
They recorded the stratigraphy.
Yes. The text details how they meticulously mapped the layers of the mound as they descended. They noted alternating, convex layers of earth, thin strata of sand, and layers of gravel.
Okay, let's talk about the mechanics of those layers. because some skeptics at the time still argued that these mounds might just be natural formations, left behind by ancient floods or retreating glaciers.
But Squire and Davis pointed out a fundamental rule of geology. Water deposits material in flat, horizontal layers as it settles.
Right. But the layers inside the mounds were perfectly convex.
They curved over the center, forming a dome shape.
You only get that specific stratigraphy if human beings are walking up a ramp and systematically dumping baskets of earth, sand, and gravel, layer upon layer, over a central point.
Exactly. It was an airtight, empirical argument for artificial origin.
But the stratigraphy solved an even bigger problem for them. I want you to picture this. You are digging in a mound, and you find a skeleton, and next to it is a metal button from the 1700s.
Uh-oh.
Right. Does that mean the mound was built in the 1700s? How do you know that artifact isn't from someone who just dug a hole and dropped it there centuries after the mound was actually built?
Temporal contamination is the absolute nightmare of every archaeologist.
It really is.
Squire and Davis solved it by using the continuity of those thin, convex sand layers to determine if a mound had been disturbed.
Because over the centuries, later, Native American tribes would often bury their dead in the upper portions of these ancient mounds.
It makes total sense. You find a pre-existing dry hill that stands above the floodplain, and you think, well, that's a great place for a grave.
Without necessarily knowing who built the hill 1,000 years earlier.
Precisely. And when those later tribes dug their graves, they would inevitably break through those upper layers of sand. Squire and Davis noted that if the strata were broken, the burials were recent.
I like to compare those undisturbed sand layers to an unbroken wax seal on a sealed letter.
Oh, that's a great analogy.
Right, because if the wax seal is broken, you know someone has tampered with the contents.
Yeah.
But if you dig down and those incredibly thin sand layers are perfectly intact, completely unbroken all the way across the walls of your 5-by-9-foot shaft, then you have absolute scientific certainty.
You know that whatever is underneath that layer has been there since the very day the mound was built.
By documenting the exact strata, they established a chronological timeline within a single structure.
It allowed them to isolate the original, undisturbed artifacts of the true mound builders at the base, completely separating them from centuries of historical mix-ups.
So they followed these unbroken sand layers down, proving no one had disturbed the earth since it was built. But what were they actually protecting down there?
That's the big question.
When they hit the bottom of the mounds on the Scioto River, they didn't find graves. They found ash.
They discovered the altars of fire. This is where Squire and Davis's excavations revealed a deeply complex religious and economic life.
Let's focus on a site they named Mound City. It is a group of 26 mounds, all contained inside one massive earthwork enclosure.
And when they sank their shafts down through the unbroken wax seals of these specific mounds, resting right on the original surface of the earth, they found symmetrical basins of fine clay.
These clay basins were perfectly shaped, round, square, or oval.
But what was truly remarkable was the thermal alteration.
Yeah, explain that.
These clay basins had been baked to extreme hardness by intense, continuous fire.
The text specifies that the clay was burned up to 22 inches deep.
22 inches.
Think about the physics of that. A regular campfire might bake the soil an inch or two. To bake solid clay almost 2 feet deep requires a roaring inferno.
Sustained over an incredibly long period of time.
And deposited directly into these altars, right into the fires, were incredible treasures.
These were offerings. Everything placed in these basins had been subjected to the immense heat, often fracturing and shattering from the intensity.
The text has amazing detailed descriptions of these artifacts. They found over 200 intricately carved porphyry pipes.
And we really have to talk about porphyry.
What is it exactly?
It is an igneous rock, incredibly hard, much harder than marble or limestone, yet these pipes were sculpted into astonishingly accurate animal forms.
Herons, frogs, beavers.
The detail was so precise that zoologists could identify the exact species of the animal just by looking at the stone carving.
Wow. But to carve porphyry with that level of anatomical precision, without hardened steel tools, that is a staggering technical achievement.
That requires sand, water, and friction, just slowly wearing away the stone over thousands of hours.
It implies a society that has specialized artisans.
Yeah.
People whose entire job is to create these masterpieces.
Which means someone else is growing the food to feed them. You have a divided labor force.
And the treasures didn't stop at stone. They found copper axes and thick copper ornaments.
And Squire and Davis noted the metallurgy here, which is fascinating. This copper was hammered cold from pure native copper.
Which is a very specific metallurgical process, right? They didn't smelt the ore by melting it down into a liquid and casting it?
No, they pounded it into shape. But cold hammering copper makes it brittle. It will eventually crack.
So how do they do it?
To shape an axe, you have to hammer it, then gently heat it, which is called annealing, to soften it, then hammer it again.
Over and over.
It shows a deep practical understanding of the material properties of metal.
They also found mica, this shiny, flaky mineral cut into perfect geometric shapes and crescents.
Thousands of pearl beads, too.
But the thing that really made me stop and reread the page was this. In the ashes of these altars, they found obsidian.
Volcanic glass.
Volcanic glass shaped into spears and knives. Wait a minute. Volcanic glass in Ohio.
This raises an important question. Where did it come from?
Yeah.
Because there are no volcanoes in Ohio. If we connect this to the bigger picture, we were looking at empirical evidence of a massive continent-spanning supply chain.
Let's trace the map they built just from the contents of these altars.
Yeah.
The native copper came from the shores of Lake Superior, hundreds of miles to the north.
The mica came from the Allegheny Mountains to the east.
The pearls and marine shells came from the Gulf of Mexico to the south.
And the obsidian, that had to come from the distant west, either the Rocky Mountains or central Mexico.
Just by scientifically logging the items in these fire pits, Squire and Davis mapped a trade network that spanned thousands of miles.
They didn't need to guess about whether these people were isolated. The empirical evidence proved they were tapping into resources across the entire continent.
You don't have obsidian traveling from the Rockies to Ohio without well-established routes.
Right, diplomacy and an economy capable of supporting that kind of long-distance exchange.
It is breathtaking. It completely rewrites the assumption of a sparsely populated, disconnected frontier.
Absolutely.
But while Mound City was defined by fire and sacrifice, Squire and Davis's systematic excavations revealed that other mounds served very different purposes, highlighting the vast diversity of the culture.
Because not every mound was an altar, they identified a second major type, the sepulchral mounds.
Cities of the dead.
Exactly. These were distinct from the altar mounds. Instead of baked clay basins, they usually contained a single skeleton at the base, often encased in a complex timber or log vault.
The standout example they highlight is the Grave Creek Mound in West Virginia. This thing was a monster, 50 feet high.
Massive.
And instead of just sinking a vertical shaft, they mapped it using horizontal excavation, driving a drift straight into the side of the mound.
And inside, they found distinct timber vaults containing skeletons. It was a massive, labor-intensive monument dedicated entirely to the dead.
And then there is a third category, which represents a massive shift in architectural style, the temple mounds.
These are mostly found in the South. Instead of the cone shapes we see in the Ohio Valley, these are massive, flat-topped, truncated pyramids.
They're built with graded ascents, essentially giant earthen ramps and flat terraces.
Likely serving as the foundations for massive wooden structures or temples.
The absolute granddaddy of them all, which the text discusses, is Cahokia in Illinois. The source material notes that the main pyramid at Cahokia contains 20 million cubic feet of earth.
It's hard to even picture that.
I want to give you a true sense of scale for that number. A standard modern dump truck holds about 400 cubic feet of dirt. To move 20 million cubic feet, you would need 50,000 modern dump trucks.
And they did it by hand.
Exactly. Dug with stone or shell tools, carried in woven baskets that held maybe 50 pounds at a time, dumped and then stamped down.
Basket by basket.
50,000 dump trucks worth of soil. That is the equivalent of building the Great Pyramid of Giza, but doing it entirely with dirt.
It is a staggering logistical feat. And it implies something fundamental about the mechanics of their society.
What's that?
You cannot feed an army of earth movers year after year by just hunting deer and gathering berries.
Oh, you would exhaust the local game in a month.
Right. These massive civic works imply an incredibly dense, highly organized, and deeply agricultural population.
You need massive, sustained agricultural surplus, vast fields of corn, just to free up the thousands of laborers required to build Cahokia.
The scale of the architecture proves the scale of the agriculture.
So we have the altars of fire, the sepulchres of the dead, the massive temple pyramids. But perhaps the strangest earthworks of all are found in the Northwest, specifically in Wisconsin.
The animal effigies.
Yes. Relying on surveys conducted by R.C. Taylor and Professor Locke, Squire and Davis include detailed accounts of mounds shaped like gigantic animals.
Bears, foxes, birds, some of them stretching over 150 feet long, molded perfectly out of the prairie soil.
And what I love is how Professor Locke approached them. He didn't just sketch a rough picture and say, well, it looks like a fox.
No, he applied that exact same rigorous scientific approach that Squire and Davis demanded.
He recorded exact anatomical measurements of the earthworks. He would measure the distance from the, quote, eye to the shoulder, end quote, and from the shoulder to the foot of the earth and animal.
He was capturing their exact proportions to prove they were intentional, scaled representations of wildlife, not just random lumps of soil.
It is a perfect example of keeping the scientific methodology consistent, even when the subject matter changes from the pure geometry of the Ohio squares to the animal effigies of Wisconsin.
It's all about the data.
So let's step back and look at what they have accomplished so far. Through their meticulous surveying, we know what they built, we know how they built it, moving tens of millions of cubic feet of dirt.
We know they traded across the entire continent.
Right. But one massive scientific question remained for the authors, the biggest mystery of all. When were they built? How old is this civilization?
This is perhaps their most elegant deduction, because we have to remember, this was 1848.
Right.
Radiocarbon dating, which modern archaeologists use to date organic material, wouldn't be invented for another century.
So what does this all mean? Without carbon dating, without a written calendar left behind, how did Squire and Davis scientifically calculate the age of the earthworks without resorting to guesswork?
They turned to the natural world. First, they used botany as a biological clock.
Okay, how did that work?
Well, when the first European settlers arrived in these valleys, these massive mounds and geometric enclosures were already completely covered by primitive, old-growth forests.
They weren't bare earth.
No, they looked like natural hills covered in huge trees. Squire and Davis literally cut down the massive trees growing directly on top of the earthwork walls and counted the annual rings.
And they found trees that were 600 to 800 years old, just growing right out of the top of the embankments.
But that was only the minimum age.
Why?
Because they also noted that these 800-year-old trees were often growing out of the decayed, crumbling remains of equally massive predecessors.
Think about the timeline that requires. After the mounds were finally abandoned, seeds took root. A forest grew, lived its entire lifespan of many centuries, died, decayed into rich soil,
And then another old-growth forest grew on top of those remains.
and lived for 800 years before Squire and Davis came along with an axe to count the rings.
Exactly. That pushes the timeline back incredibly far.
But the botany was just the warm-up.
Yeah, the most brilliant deduction they made, the one that truly cemented the antiquity of the mounds, was based on geology, specifically the formation of the river terraces.
I love this part because it is so incredibly logical once you see it. The rivers in the Mississippi and Ohio valleys have slowly cut down through the earth over millennia.
Right. As a river cuts deeper into the bedrock, it leaves its old floodplains behind as distinct, step-like terraces on the sides of the valley.
Like giant stairs.
Yes. The highest terrace is the oldest. That's where the river flowed tens of thousands of years ago. As you walk down the steps toward the water, the terraces get younger.
The lowest terrace, the one right next to the modern river, is the newest floodplain, formed most recently.
So Squire and Davis mapped thousands of these earthworks across multiple river valleys. They found them heavily concentrated on the second terrace.
They found them on the third terrace.
They found them on the fourth, the highest terraces.
But as they looked at their exhaustive data, they noted a complete 100% absence of any works on the first terrace, the lowest and latest formed floodplain.
And that is the geological smoking gun.
Why does that matter so much?
Because human civilizations, especially agricultural ones that rely on river transport, always build near the water.
You want to be close to the river.
Exactly. The first terrace has the most fertile soil and the easiest access to the river.
So if that lowest terrace had existed when the mound builders were alive, they absolutely would have built their cities and enclosures on it.
They wouldn't have ignored the best land. The fact that there isn't a single earthwork on the first terrace scientifically proves that the ancient civilization flourished, built their massive cities, and completely vanished before the river had even finished forming its current lowest floodplain.
It is an airtight empirical argument. They didn't need to invent a myth about wandering tribes or ancient giants. They used the earth itself to date the earthworks.
The river carving down, step by step, century by century, acted as a geological clock.
And the earthworks are just stranded up there on the upper steps of time, waiting for someone with a surveyor's compass to finally read the landscape correctly.
It is just brilliant deduction.
It really is. And it brings us to the end of our journey for today. We have traveled with you from the strict truth-seeking mandates of the young Smithsonian Institution through the muddy, mosquito-filled forests where Squire and Davis dragged heavy chains to prove the existence of giant, perfect octagons,
We descended down the square vertical shafts into the altars of fire.
examining the mechanics of cold-hammered copper and tracing trade routes to the Rockies through pieces of obsidian.
And finally, we climbed up the geological terraces of time to see how rivers and tree rings proved the immense antiquity of it all.
Squire and Davis didn't just uncover artifacts, they brought the scientific method to the American frontier. They laid the bedrock for all of scientific archaeology in this hemisphere.
They taught a young nation how to look, how to measure, and how to deduce truth from the soil without ever letting romantic imagination compromise the hard facts.
And that leaves us with a final lingering thought for you to take away. If a civilization so vast and powerful, capable of moving tens of millions of cubic feet of earth by hand, capable of engineering perfect geometry on a massive scale, and maintaining supply chains from the Rocky Mountains to the Gulf of Mexico,
If they could vanish so completely that their actual names are lost to time, leaving only silent geometry beneath ancient trees.
what monuments are we currently building on our own latest terrace that will puzzle the scientific surveyors of a distant, unknown future? We are sitting here today in our modern world, confidently categorizing our reality, but someday our cities might just be the murky, mysterious earthworks for someone else's surveyor compass. Thank you so much for joining us on this deep dive into the source material. We will see you next time.